Welcome back to my YouTube channel Grandpa Mathematics. Now we are going to derive all these formulas and you have to remember all these formulas. So in this integration, integral dx by x square plus a square, what we have to do, we have to make the denominator as a single term. How to make the denominator as a single term here? By putting x is a tan theta. If you put x as a tan theta, it become a square tan square theta plus a square, and once you take a square outside, it will become tan square theta plus 1, that will become secant square theta. The denominator becomes a single term. Or put x is equal to a tan theta if you differentiate this, dx is a secant square theta d theta. Therefore, 1 becomes I is equal to integral dx is what? Dx is a secant square theta. So, a secant square theta d theta by x is a tan theta, x square is a square tan square theta, so a square tan square theta plus a square. Now the denominator, take a square outside, you'll get a secant square theta by, we take a square outside, tan square theta plus 1 here what happens now? A secant square theta by a square tan square theta plus 1 is secant square theta. So secant square theta d theta. Therefore, I is equal to integral 1 by a into d theta. Integral d theta is what? Is nothing but theta plus constant. But what is theta? Here you can see x is a tan theta. Tan theta is x by a. We call this as 3. So from 2 we get tan theta is x by a. Tan theta is x by a. From here you can get theta is equal to tan inverse x by a. Tan theta is x by a, theta becomes tan inverse x by a. Therefore, 3 becomes I is equal to 1 by a, theta is tan inverse x by a plus constant. So this is the answer. So what is integral dx by x square plus a square? So this is nothing but 1 by a tan inverse x by a plus constant. So you can use partial fraction to find the value of this integral. X square minus a square can be factorized as x plus a into x minus a. Therefore, we can write let 1 by x square minus a square, this is equal to a by x plus a plus b by x minus a, where a and b are arbitrary constants. So once you find the value of a and b, so in place of 1 by x square minus a square, we can substitute this value, then we can find the integral. How to find the value of a and b? Just to multiply throughout by x square minus a square. If we multiply throughout by x square minus a square, the left hand side becomes 1 is equal to, this becomes a into x minus a plus b into x plus a. When you multiply this term by x square minus a square, this becomes 1. When you multiply this term by x square minus a square, that x plus a get cancels, x minus a comes here. Again, if you multiply this term by x square minus a square, x minus a term get cancels and x plus a is coming here. Now, we have to find the value of a and b. First substitute x is small a, so that this term will become 0, we can find the value of b. So put x is equal to a, 1 is equal to, once you put a minus a, 0. So this term becomes 0 and b, a plus a, 2a. So 2ab is equal to 1. This gives b is equal to 1 by 2a. 2ab is equal to 1. So b is equal to 1 by 2a. Now to find the value of a, we have to make this term 0. So if you put x is minus a, so this will become 0. We'll get the value of capital A. So put x is equal to minus a, we get 1 is equal to a into minus a minus a. Here minus a plus a, this will become 0. So this term will become 0. So this gives the value of a, capital A, as 1 by minus 2a. So minus 1 by 2a. So now 1 by x square minus a square is nothing but, for a we can put minus 1 by 2a, for b we can put 1 by 2a. Therefore 1 becomes a is nothing but minus 1 by 2a into 1 by x plus a plus b is nothing but 1 by 2a into 1 by x minus a dx. If we integrate this, so we will get I is equal to minus 1 by 2a integral dx by x plus a plus 1 by 2a integral dx by x minus a. Integral, if we differentiate x plus a, we will get dx. So this value of this integral will be log of x plus a plus 1 by 2a times. Again, if we differentiate x minus a, we will get dx. So the value of this integral will be log of x minus a plus constant. Now we can take 1 by 2a commonly outside. Then we'll get this term. I'll write first log of x minus a this term comes here minus log of x plus a. This term comes here and this goes minus. So again this is in the form of log m minus log n. So what is log m minus log n? It's nothing but log m by n. So this is nothing but log of m by n plus constant. So this is the answer. To find the value of integral dx by a square minus x square, so we have to follow the same method. From here, let us see how to get it. Integral dx by a square minus x square. That's nothing but minus 1 times 1 by 2a log of x minus a by x plus a x square minus a square minus x square. We are multiplying this with minus 1, we are getting this. So minus 1 comes here. This minus 1 should take here 1 by 2a log of x minus a by x plus a power minus 1 plus c m log n or n log m is equal to log m power n. This formula we are using. Here n is minus 1. So when minus 1 means you have to take x plus a to numerator, x minus a to the denominator. So x minus a comes to the denominator, x plus a goes to numerator. Modulus of a minus x and modulus of x minus a both are same. Modulus of x minus a is equal to modulus of a minus x. When I take modulus, these two values are same. So this we have derived from previous formula, but we can do directly. So now we have to find the value of this integral dx by square root of x square plus a square. Here a is a constant. So what value we have to substitute for x so that the denominator becomes a single term. So if you put x is a tan theta, x square is a square tan square theta. We take a square outside, then it will become tan square theta plus 1. That becomes a secant square theta. So that means we have to take that x is equal to a tan theta. When you take x is a tan theta, dx is, if we differentiate this with respect to theta, dx is a secant square theta d theta. Therefore 1 becomes dx. Dx is a secant square theta d theta by x is a tan theta. So this is a square tan square theta plus a square. Now we'll take a square commonly outside. A square into tan square theta plus 1 if we take a square outside the integral, outside the square root, that becomes a. Then tan square theta plus 1 is secant square theta. Then we take outside the square root, that becomes secant theta. So this becomes now integral secant theta d theta. Okay, secant square theta by secant theta is secant theta d theta. To find the value of integral secant theta d theta, so we have to multiply numerator and denominator by secant theta plus tan theta. So this you have to remember. So integral secant theta into secant theta plus tan theta by secant theta plus tan theta d theta. So this steps we have to remember only. The secant theta d theta means to get the value of this integral, we have to multiply numerator and the denominator by secant theta plus tan theta. Now we multiply this secant square theta plus secant theta tan theta by secant theta plus tan theta d theta. Now, if we differentiate secant theta, what will come? Secant theta tan theta comes. Plus, if we differentiate tan theta, secant square theta comes. So that means if we differentiate this denominator, we are getting the numerator. The value of this integral is log of the denominator plus constant. So whenever if we differentiate the denominator and if we are getting the numerator, the value of the integral will be log of the denominator plus constant. Or we write this as integral dy by y, where y is secant theta plus tan theta. So if we take this is y, written y, if we differentiate this, we are getting this. This becomes dy. So this is nothing but log y plus constant is nothing but log of tan theta plus secant theta plus constant. Now we have to replace theta in terms of x. From 2 we get x is a tan theta. From here we can get tan theta is x by a. Then we have to get the secant theta value. To find the secant theta value, we have to express secant theta in terms of tan theta So we know that secant square theta is 1 plus tan square theta. So you can write this as secant square theta, square root of secant square theta. So square root of 1 plus tan square theta. So square root of 1 plus x square by a square, or a square plus x square by a. Therefore 3 becomes integral dx by square root of x square plus a square is nothing but log of I is nothing but integral dx by x square plus a square is nothing but log of tan theta. Tan theta is x by a plus secant theta is square root of x square plus a square by a plus constant. So here we can write log of x plus square root of x square plus a square by a plus constant this is log m by n form. Log m by n. How you can write log m by n? Is nothing but log of m by n is log m minus log n. So this we can write log of x plus square root of x square plus a square minus log a plus constant. Therefore we can write integral dx by square root of x square plus a square plus log of x plus square root of x square plus a square plus some other constant. Some other constant we can put c dash and then c minus log a is c dash. So let us find the value of this integral dx by square root of x square minus a square. Again we have to make denominator as a single term. How to make x square minus a square as a single term? Because secant square theta minus 1 is tan square theta is coming. So let x is equal to a secant theta. Okay, let x is equal to a secant theta. X square is a square secant square theta. By taking a square outside, secant square theta minus 1 will come, that will become tan square theta. So it will come outside the square root. So this gives dx is equal to a into secant theta. If we differentiate secant theta, tan theta, d theta. Therefore 1 becomes I is equal to integral dx is a secant theta tan theta d theta, a secant theta tan theta into d theta by x square. X is a secant theta, x square is a square secant square theta. Minus a square Again we'll take a square commonly outside from this to a square into secant square theta minus 1 Now again we take a square outside the square root, that will become a. Secant square theta minus 1 is tan square theta. Square root of tan square theta is tan theta. So this gets simplified to integral secant theta d theta. Okay. This gets simplified to integral secant theta d theta. Find the value of this integral secant theta d theta. So we already seen, to find the value of this integral, you have to multiply numerator and the denominator by secant theta plus tan theta. So integral secant theta into secant theta plus tan theta by secant theta plus tan theta. If we multiply the numerator, secant square theta plus secant theta into tan theta by tan theta, I will write first plus secant theta d theta. If we take differentiate tan theta, you get in secant square theta, plus if we differentiate secant theta, you get in secant theta tan theta. So this becomes integral dy by y, where y is equal to secant theta plus tan theta, or tan theta plus secant theta. So what the value of this? Log of y plus constant what is y? Secant theta plus tan theta plus constant. We call this as 3. So dx by square root of x square minus a square is log of secant theta plus tan theta is coming. We know from 2 x is, we take x is a secant theta. We have taken x is a secant theta. So secant theta is x by so tan theta, so tan square theta is secant square theta minus 1. So secant theta is x by a, so x square by a square minus 1. So x square minus a square by a square. So what is tan theta now? Square root of x square minus a square by a. We call this as 5. Substitute 4 and 5 and 3. We get is equal to log of secant theta is x by a. Tan theta is nothing but square root of x square minus a square by a plus constant c dash. So this is nothing but log of x plus square root of x square minus a square by a plus c dash x plus this by a. This is in the form of log m by n. So we can write as log m minus log n. So it is nothing but log of x plus square root of x square minus a square minus log a plus c dash. Therefore, integral dx by square root of x square minus a square, this is equal to log of x plus square root of x square minus a square plus constant. So this is the answer. Square minus x square. So what value we have to substitute for x? So then a square minus x square becomes a single term. If we put x as a sin theta, x square is a square sin square theta. If we take a square outside, 1 minus sin square theta will come. That is nothing but cos square theta. So we can take, put x is equal to a sin theta if we differentiate this, we will get dx is equal to a cos theta d theta. Therefore, 1 becomes I is equal to integral dx. Dx is a cos theta d theta square root a square minus x square. X is a sin theta, x square is a square sin square theta. A cos theta by square root of, take a square commonly outside, then this becomes 1 minus sin square theta d theta a cos theta if we take a square outside the square root, that will become a, and 1 minus sin square theta is cos square theta, square root of cos square theta is cos theta, so it becomes cos theta d theta. So what this becomes now? This becomes simply integral d theta. What is the value of integral d theta? It's nothing but theta plus constant. What is theta? We know that x is a sin theta. From here we have to find the value of theta. From 2 we get sin theta is x by a this gives theta is equal to sin inverse x by a. We call this equation as 3. Therefore, 3 becomes I. I is nothing but dx by square root of a square minus x square. This is equal to theta. Theta is nothing but sin inverse x by a plus constant.